today's topic is mealy model. We are going to design the mealy circuit, mealy state diagram from the circuit given below. Okay, so the question is construct the transition table, and state diagram for the sequential circuit given below. So the sequential circuit is given. We need to find the transition table, and state diagram. This is a sequential circuit given. The step one is to find the input and output equation. So how do we find the input output equation? From the given sequential circuit. Okay, so see the sequential circuit, the output is denoted as Z. Yes, so we need to find the output Z first. So Z equal to X. To X. This is nothing but from the diagram. You can see here. You can see here in this diagram. So Z equal to it is a AND gate. The Z is connected to an AND gate. The AND gate is connected to X and F2. So the output is equal to F2X. Yes, and then F1. F1 is nothing but Q1. This question, so we have F1 here. F1 is connected to the first flip flop, so F1 equal to Q1, and F2 equal to Q2. F2, the F2 is connected to the second flip flop, so it is Q2. Fine. D2. So D2 is F1, F2 from where the D2 is here. In this circuit, D2 is connected to a 3-input AND gate which is connected to F1, F2 bar and X. So we get D2 equal to the equation D2 equal to F1, F2 bar and X. Okay. Now D1 equal to X bar plus F1 F2 bar. This is again from the diagram. D1, where is this D1? D1 is here. D1 is connected to a OR gate which is adding X bar plus F2 bar F1. Okay. So this equation X bar plus F1 F2 bar we got from the diagram above. Step 1 is over. We found the input output equations. Going to the step 2, deriving the transition equation. So to derive the transition equation, we should know the characteristic equation of flip flop. So here we are using D flip flop. The characteristic equation of D flip flop is nothing but Q plus equal to D. Okay. So here we have two flip flop. So F1 equal to D1. Just because the characteristic equation is nothing but D itself, right? So because we are taking for the first flip flop, the characteristic equation will change as D1. So D1 is nothing but we already got here. D1 is nothing but X bar plus F1 F2 bar. So we need to substitute D1 equal to X bar plus F1 F2 bar, and then we need to simplify it here. So for simplification, we are introducing two terms, F1 plus F1 bar, nothing but 1. Again another term, F2 plus F2 bar, nothing but 1. Why? Because so these two terms are absent here with X. But previously when we are dealing with the equation, that two terms are also there, right? So these two terms are simply multiplied here, but anyhow the multiplication output is 1. Any term multiplied by the complement term you will get 1. Similarly, any term multiplied by the complement term, the answer is 1. 1 into 1, again it is 1. So it is simply for simplification. For expanding, we are introducing the two terms here. Similarly, here we are introducing X plus X bar. Now, where it is? Yes, we are multiplying it inside and expanding the term, and after expanding we get it like this, F1 F2 X bar, F1 F2 bar X bar. This big term will come. Now This big term is represented in binary like 110, 100. The bar F1 is taken as 1, F2 bar is taken as 0, X bar is taken as 0. Similarly, all the terms are converted into binary. So step 2 is over. Now step 3 is nothing but next state map. So how do we get the next state map? Nothing but F1, F2 is the two terms and the third term is X. So we make a map keeping F1, F2 in one side and X in the other side combinations. Now when F1, F2 and the X 3 are 0, 0, 0, 0, here we are marking it as 1. Why? Because the previous step we simplified and got on binary term, right? In that binary term, we have the term 0, 0, 0. Yes, nothing but F1 0, F2 0, X 0, 0, 0, 0 is there. So the presence of the term is noted here in the step 3 as 1. Okay, 1 minute. Let me see if I can take chalk.
Your school vehicle is the
Okay, and we'll go back to the topic. Okay, similarly 0, 0, 0 is 1. Now the next term is 0, 1, 0. Again we need to see the step 2, the final answer 0, 1, 0. If we have it, we need to mark it as 1. So where is 0, 1, 0? It is here the third term 0, 1, 0. We need to mark it as 1. The next term is 1, 0, F1, 1, F2, 0, x equal to 0. So the third term 1, 0, 0, that is also there. So you mark it as 1. So like this you make the full F1 table. So what about F2? F2, you see this table here, only one place it is marked as 1. Remaining all the places it is marked as 0. It is because we are directly taking this from this equation d2 equal to F1 F2 bar x. It is not simplified. Why it is not simplified? Because it has all the three terms in it. Nothing but 101. Only 101 is present. Remaining all the terms are absent. So in this table also only 101 is marked 1. Yes, and the remaining all the terms are marked 0. So this is your step 3. Now coming to step 4. Coming to step 4, here it is, that is plot the transition table. For the transition table, we need to make a present state, we need to make for the transition table, we need to make the present state and next state. Present state is nothing but F1, F2, two inputs. You're just writing the two input combination 0, 0, 0, 1, 1, 0, 1, 1. Next state comes for two inputs x equal to 0 and x equal to 1. Okay, so when x equal to 0, what is the next state? When x equal to 1, what is the next state? So this has to be derived from the previous table. So when the input is 0, 0, F1, F2 is 0 and x is equal to 0, what is your output? F1. Listen again clearly. When the present state 0, 0 and x is also 0, Your output F1 plus is 1 here. It is directly taken from the step 3 table. See, the step 3 table as it is 1111 is written here 1111 0010 0 0010. It is for x equal to 1. Okay, it is for x equal to 1 0010. It is written as it is. For F1 in the next state F1 plus for x equal to 0 F1 plus for x equal to 1 both are taken from the step 3 F1 plus table. Okay, similarly in next state F2 plus x equal to 0 F2 plus x equal to 1 is taken from step 3 F2 plus table. This as it is, you take this 400000, write it here 0010 in the F2 plus table is written for x equal to 1. Okay, now coming to output x equal to 0 x equal to 1. So the equation for output is nothing but z equal to f2x. Equation for output is nothing but z equal to f2x. So F2 is nothing but the present state input 0, x is your next state. So Z equal to F2x. So for x equal to 0, the F2 value is taken from here. Okay. So you get present state F2 multiplied by x equal to 0. So whatever there in the F2 multiplied by x equal to 0, you get all output as 0. So when the output for x equal to 0 will be 0 in all the cases. You can see the table here, the last table, the output x equal to 0. You get for the 4 cases the output is 0 because output equation is f2 into x. Anything multiplied by x, you get anything multiplied by 0, you get the output 0, right? Similarly, when x equal to 1, f2 multiplied by 1. So present state f2 is 0101. 0101 is multiplied by 1. You get the same 0101. I hope the output column is clear. Now coming to step 5. Your state table. In state table, you have to mention it with the alphabets. In the previous table, wherever you have 0, 0, it is mentioned as A, 0, 1, it is mentioned as B, 1, 0 is mentioned as C, 1, 1 is mentioned as D. So in the next this table you see, wherever 0, 0 is there, that is changed as A, B, C, D. So it is just following the previous table, but you need to change it to alphabets. That's all with the step 5. Coming to step 6, draw the state diagram. State diagram. Now the step 5 table helps you to draw the state diagram. Okay. So when the present state is A, next state is C. See the diagram. See the table here clearly. Present state is A, next state is C. But what is the condition? X is equal to 0 and output is again 0. X is equal to 0, right? So we need to draw it like it moves from A. It moves from A to C. It moves from A to C. When the present state is 0 and the output is also 0. 0 by 0. 0 by 0. It is moving from A to C. Present state is A. Next state is C. When x equal to 0 and the output is 0. 0 by 0. Okay. Now the same. It is moving from B to C. When x equal to 0 and the output is 0. You see, it is drawn like that. When it is moving from B to C, present state is 0 and the next output is 0. X equal to 0 and output is 0. Again, see here, it is moving from C to C when x equal to 0 and output is again 0. Yes. So like this, you can draw this diagram, seeing all the values from the table, you can plot it in the state diagram. I hope it is clear. Thank you.